Day from the Fred Hutch Cancer Center in Seattle. Thank you so much for letting me. 10th anniversary. The Fred Hutch is a dedicated standalone cancer research center. What's changed in the last 2 years is now, it's hard to explain the politics of healthcare in America, but we do have an on-site clinic that's integrated into our facility, and that wasn't the case 2 years ago. And we've also doubled our clinic space. So we have what we call PIs in America, principal investigators. So we have around 300 of those, and a MD, PhD, they work in the clinic, they do research, and they also teach at UW Medical at the university. So a lot of those people have lots of titles, and joining the clinic to the research center eliminated one of their titles. So life is simpler for them now. So we do have graduate students. We're a non-degree granting educational center. And we're home to 3 Nobel laureates, and we're very excited about Dr. Baker, who shared the chemistry prize this year with AlphaFold. And it's the 50th anniversary this year for the Fred Hutch, which in Europe, with the people here who probably have centers that are centuries old. So 50 is like a pretty small number, but I think we might be one of the older centers in terms of like purely only doing cancer research. The first successful bone marrow transplant for leukemia was done at the Fred Hutch, and that was our first Nobel Prize. Our cluster is in a state of flux. We still have a 5-year-old center that's Skylake. That's the bulk of our cluster from 2020. That's the first time we put a GPU in every node. Prior to that, we never had any requests. And when we initially put the GPUs in, we had no requests for GPUs, and now everyone is asking for GPUs. Last fall, we were able to add some Zen 4, and these have LS40s, and we have 4 per node. So you run up to 4 jobs on a single node and access GPUs. Unfortunately, they don't have the NP link, so you have to use a lot of software to glue them together. So a little bit of choice if you want to have like large memory models. And our local system administrators refer to them as snowflakes, but we do have individual machines bought by researchers. So we do have some H100s and A100s on site. Right now I'm supporting 4 architectures. So again, 2 of those are snowflakes, but moving forward, we hope everything's going to be Zen 4, and we're still running Ubuntu, which we like it. We've been doing it for since version 12. Okay.
Just leave it alone.
Okay. Our cluster nodes are very, very stripped down. They may not even, this is true, they may not even have make. It's an option with Ubuntu. So everything is very module dependent. What's really changed in the last 2 years is the diversity of software we're supporting. So things like Aptainer. We have a Docker Swarm now. We have a lot of people with containers, so it's like, where can we run those? There's a lot of security problems around storage with that. And then open demand, we've been talking about this for years, and we're so close to getting it rolled out. We hope that comes out very, very soon. LMOD, I log everything, the syslog, and I do very JSON type logging key value pairs that I'm able to mine. I use the top level name like R, and I can dig in the R and get all 20 versions that we support and take that. We can also log the Slurm ID along with that, and I also log the UID, of course. So I wish I looked at this data more often. I was updating the slide, and the last time I was here, we were loading 1 million versions of R a year, and now we're up to 3, and our cluster hasn't grown that much, so I'm kind of interested. And I see like somebody loading GCC is in the top 3, so that's going to cause me to do call somebody on the phone and ask them what they're doing. So it's good to look at this data maybe more than once a year. But this is what it looks like at the local site. And I've been a big champion of site-based packages. So you see like FHR and FH Python. So those are the Fred Hutch versions of R. So Fred Hutch R is R, RCRAN, R bioconductor, plus about 400 more packages that I add to it. The same thing. So it's, oh my gosh, I'd have to look at it, but it's a long list of like almost everything that says anything that has to do with the bioinformatics in the Python world. It's a very long list of modules, all just glued together. And so when you look at your Python path after loading this, it's pretty impressive. When I first started giving these talks, I really didn't have, like, I think when I started at the Hutch, I might have gotten one software request a month or maybe one every other month. Now we're getting 140 a year. 2 years ago, I also started putting additional tags in that software tracking. So, you know, what is going to be a new PR versus just an updated package number? A lot of people have questions. Not able to build is a new category. There's just so many crazy bioinformatics things. So I'm trying to keep track of like things I'm having a lot of difficulty with. A lot of software I get requests for install are not in EasyBuild. It's very frustrating. So there's a lot of work creating modules all the time. And I use this thing called EBCB, which is my EasyBuild container build, which rhymes with the nightclub in New York City from the 90s. And it's a very complicated container. It shouldn't be that complicated. And then we have a lot of commercial software. We have lots of instruments. And of course, AlphaFold 3, people were asking me for the pre-release in the summer. So just the quickest thing I could do, just build a CIF and put it out there. We now have Apptainer on every node. So we've switched from using an EasyBuild to using the OS package. Kind of the trends that are going on. Gosh, people want to use LMOD with everything. People want to connect remotely with VS Code and run Python and R, RStudio. That's a huge product where we are. People want to load a bunch of Python stuff and then start a virtual environment. And gosh, I don't know if everyone has this frustration, but you know, Python path isn't sucked into your virtual environment. So we have a really crazy local script that feeds that back in. So after you create your virtual environment, you run this script, it sucks in all of your modules, and then when you launch activate your environment, you have all your modules there. Just container requests or just everyone has everyone shows up with a container. That's like almost a weekly thing.
So there is this thing called SHPC by the same people who created Apptainer, and they have a huge repository of bioinformatics containers, like thousands of them there.
Yes.
Well,
yes.
Maybe you know that one. Yeah. SHPC is very nice because you do SHPC install and it downloads the right container for you. It has,
yes.
Yeah,
a lot of our users they don't even open a ticket. They just go grab it and start using the cluster directly with Slurm. There's a lot of stuff that doesn't even come through a help desk ticket. People just go and do it themselves. Again, GPU usage, lots of people asking for that. There's been a new AI tool out, SCGPT, which would be great if that was in EasyBuild. It's a class product and it's not in there yet. It's single cell biology and it's a giant model of all the single cell sequences that people have. And it's like AlphaFold in the sense that it's a community collaboration. That was very difficult to install. And again, Open on Demand's coming, EBCB, my container build environment. Inside EBCB now, I keep the dev.
No, I was just wondering, do you have this script somewhere for the virtual environments?
You know, I Google it a lot and everyone has like a suggestion and I just kind of cobbled together a lot of ideas about it. I'll try to post it somewhere. It's kind of embarrassing, but it does work.
Doesn't matter.
Like, you know, after you like load all your modules, this huge stack, this thing just looks at your environment and just manually just does it replaces LMOD, it just does individual module loads and in the reverse order. So it doesn't kind of balloon into something it shouldn't be.
Okay, we had this issue too, that users can't use their virtual environments on top of the modules. And the best way to avoid Python paths interfering with that is not using it. We have this little feature, EB-Python prefixes, that was used for using Python 2 and 3 together, more or less. But this avoids all these issues. So if your module set EB-Python prefix instead of Python path, it pretty much works out of the box with virtual environment. So you can even just change the default or the setting in EasyBuild, do a module only rebuild, and it works.
Okay. Please send me an email about that.
As for using modules in VS Code, RStudios, or JupyterLab, it's very easy to do that in Open on Demand.
Yeah.
Users can create their own environment. We set it up so that user C3C and Michael did the same thing.
Yeah, we're also looking forward to just running VS Code inside Open On Demand. It's all web-based, so you know our internal demos that are working really, really well. We just really want to get out there as soon as we can. Oh yeah, so I've started the habit of keeping the dev list of easy configs in my container now. So every time I launch my container, I'll do a pull and grab the newest ones. It just saves me a lot of time, like using the -s and whatnot, or going to the site, or just anything, that user experience thing that Simon's talking about, like what's the quickest way to get a list of the current containers. Easy update. Man, the code's been in embarrassing shape for a long time, and before I came here, I spent weeks working on it so I wouldn't embarrass myself up here. There's like 7 open issues, and they're all solved in this release. I just pushed it Wednesday. Again, the CRAN part, the R parts worked for years. It's just rock solid. The R stuff's just really good. Some small things I've noticed. Normally I build R like the same week it comes out. So I'm always right on the bleeding edge of it. And this time I was maybe 3 months behind, and already packages have changed. So the initial publication of R, I should say in Bioconductor, those versions are no longer available. It's already changed. So there's a difference between their package data and their JSON data. And the package data has the current version numbers, but the JSON doesn't. But the JSON has the descriptions and the summary, which I want for other reasons. So I've written the code to merge both of those sources into one. So that fixed a few bugs that I didn't know existed, because I've never waited months for it. PyPy got better. I used to complain about it every year, and I did read this thing about Guido. But all this was for one user, so like spending more time on it than for all that work. But the user's happy. So, but this is one of the reasons why I don't contribute sometimes. It's like this thing is it's a train wreck, And that's all I have. Thank you. Give you some time back, I think.
Okay, any questions? Yeah, we had an issue in Zoom. The Wi-Fi died, but only the last 2 or 3 minutes of your talk. So. No, not yours. It's here.
Yeah. Well, I was going to show. I do. Part of Easy Update is Easy Annotate. I was just going to show that off real quick. So here's the package list for Fred Hutch R, and it's this is statically generated. So it'll read the Fred Hutch R file, then it will read the Fred Hutch, the CRAN file, the Bioconductor file, the R file, and then anything that those bring in. So it's a really so when you load this module, this is actually what you would see in terms of your import list. So it's just not looking at one easy config. It recursively reads all of them. And then I'll link each thing to its source also. So if you want to get additional information on the package, and then the description file, like I was saying, it comes either from the website, any of multiple sources. So, and I just let people use their browser search for this, but it's kind of big. It's, yeah, that's even uglier, yeah. Yeah, hang on here. Let's see if I got a. Oh. Okay. Well, so this is a very out of date, but similar kind of list of packages.
Because there are plans to integrate Easy Update into EasyBuild, right?
Yeah, we should talk about that at the bar, yeah. If you look at the source code, there's a file called framework. So everything to do with EasyBuild, I've put in one module. So like, how do I find a module? How do I create a module name? You know, read an easy config, write an easy config. That's all in one module. And if I could just switch that out with the framework, that would be great. And I don't need EasyBuild to run Easy Update, but I do need the EasyBuild root environment variable set, because I need to be able to find all of your easy configs. So I need to be able to crawl the file directory and read in all those dependencies. Thank you.
No, do you have the, oh, I'll do the HDMI. Welcome everybody. I have to be quick because we're getting into lunch. Everybody's getting hungry. So I'm doing a little side presentation for the Digital Research Alliance of Canada. It's kind of the overall coordinating organization for the national supercomputers in Canada. We used to be known as Compute Canada. Now it's Digital Research Alliance of Canada. It's organized via regional organizations. So I myself am with Calcul Quebec because I'm based in Montreal, Quebec. The others too, like out east we have AceNet, we have Compute Ontario, and then west there is BC and Prairie's DRI, which is Digital Research. Then there's member institutions, thousands of users all across Canadian universities. Free, it goes via a contest every year, research allocation contest where allocations. Oh, right now, in 2017, we've been through a big reorganization where instead of having a lot of smaller clusters, we have now 6 national clusters. And at the moment, those ones from 2017, 2018 about are getting replaced all pretty much around the same time. So we're, of course, many of these new nodes have 192 cores per node. 5 out of 6 systems here are getting replaced. Beluga and Naval in Montreal, they're in the same data center. So everything is kind of increasing. New letters for the network. busy time for the system administrators, verification teams, etc. So the way we're using EasyBuild is same reasoning as Easy. Basically borrowed some ideas from us. It's the other way around. You don't think, oh, this is based on Easy. No, Easy is based on us. So the idea is that we're basically abstract the underlying OS, because the problem is that the underlying OS is missing packages, and so people ask, I read some installation instruction and I need to use sudo, but sudo is not allowed on your cluster. What can I do? And so we say, 15 modules, and in the old days we used to write modules by hand, so this is why it says 279. This is a few years ago. And EasyBuild automates generating. So the way we're using, same idea as Easy, that we have a compatibility layer that sits in between what's installed by the OS and differences. Like a lot of talks tomorrow will be more about Easy or first day. And so this schematic is the same between our system and Easy, except we have a thicker compatibility layer, so to say. More stuff in the compatibility layer that gives us fewer modules to load. So for instance, like zlib is a module in Easy, but we don't have it as a module. And everything is put on CVMFS. Again, we're having more talks about that. And we'll skip over this to let you punch. So the compatibility layer, like I said, it's kind of like all the software that's not really of scientific interest, all the boring dependencies, we put that all in the compatibility layers. Bash and editors and the whole LaTeX installation. Lots of other things. Really just an abstraction layer, and put it in a module. If you've never seen a compatibility layer, you could see it as an enormous bundle, like X11 in EasyBuild is a bundle, lots of libraries, and in our case, compatibility layer is like a giant bundle of packages that is managed via Gen2 prefix. Then we've got EasyBuild and LMod. Again, we know these tools. Do we still have the old logo? Oh yeah, the old logo. If you don't know the old logo, it's there. Yes. This is a new thing. So we used to have more of a manually managed cloud nodes where we did our builds. Now that's been replaced by a Magic Castle. So if you've seen ever talk by my colleague Felix Antoine, been developer of Magic Castle, and now our build infrastructure is a Magic Castle cluster in the cloud, and we call that Archimedes, named after the ancient Greek. And so this looks like a mini cluster, like a small cluster with auto scale. So we've got our login node, you SSH to login node, and you can submit jobs. So when we test, I do an interactive job. I log into a compute node, and I do some EasyBuild stuff. I just build an easy config file, and that gets installed to my home directory. And then I have my module. I can load it and test it. And this will usually take a few tries. Sometimes it goes, I pray hard enough, it goes straight away. And sometimes it takes days of debugging, as you probably all know. And then when we're finished, we can push the EasyBuild file to GitHub, or sometimes it's an upstream easy config and may have to use try toolchain, and we don't have to push out anything. Then we can use a special EB user to pull from GitHub back to the local file system, and then we submit the -- job. So that gets to the compute node. The compute node may be auto-scaled. It could just be provisioned automatically from cloud. Then it builds the software. So the compute node then puts it into our copy of the /CVMFS, which sits on a local file system, a local parallel file system for that virtual cluster. It's called CevFS. It's a parallel file system. And then to get it into CVMFS, I SSH into publisher node right here, which has this copy of all our stuff on a Ceph directory, and /CFS there is then the Stratum 0. It's mounted. So we rsync it from the local Ceph file system into the. This is all managed via Puppet, so when a node goes down, we just bring it up and there, bar any issues. I will skip this because it's quite similar to Easy, saying, okay, when we put in into EasyBuild, the criteria are a little bit different. Basically say if it's a multiple version or scientifically interesting, we put as a module. It's been growing over the years. Now we're over 15,000 software packages. The old stuff is still there, but with a security warning. We also have a lot of Python wheels. So for Python, we tend to not install Python package via EasyBuild. We have a wheelhouse and stuff gets installed. Current environment, we have standard EUM'25. The large majority of software is installed using a FOSS 2023A or a subtool chain of that. 2023A is like TC 12.3 and OpenMPI 4.5. And we have some other tool chains as well. There's more for people who build their own software, like 2023 tool chains and NVHPC. The older stacks, like I said, are still available, but we have, particularly the 2016 and 2018, was like worries about security. Say, okay, well, yes, it's security, but it's user software. People can install whatever in the home directory. Say, okay, so if you use it, it's hidden. Even module spider will not find it, but you can still module load it, and you get a big security warning saying, at your own risk. So there are always issues with the custom prefix. This will be similar to Easy. It's like stuff that normally sits on /USR goes in the prefix. That gives some issues, particularly with commercial packages. Sometimes with Anaconda and Julia, but sometimes we have to fall back to Aptainer with all else fails. Back to our container repository for some of those. So we have this boundary between host and OS that gives some issues. We've pretty much solved them over the years. Some of them have to do with LDAP. And it works quite well. We even have now a desktop that can be used via web browser, via Jupyter Hub. Another thing, a little bit messy, that we have what we call a collapsed GC core. We can do that by having a central lib standard C++ that across the board. A little bit different from upstream because we have a core that sort of collapsed into the system tool chain. It's a little bit messy, but it works most of the time. So here's my last slide. I hope so the last slide is we have a web page, so this PDF will be on the website. You can access it. The most parts of the stack are public. There's a few things in the restricted repository. I'm still looking to collaborate a bit with Easy packages, bootstrapping that I've already borrowed for the new stack. And we're running CephFS on our Archimedes is sometimes a bit slow. And I know that the way Easy installs software is quite different from what we do, and pros and cons. I'd like to go and have a chat with Kenneth probably next week about. The other thing we've added recently is the data and container repository. So there's some software packages like Cream2. I think it was one of the early examples of something that depends on lots of things. And we've basically given up on installing it via EasyBuild. We just install the container, we unpack the container in this custom CVMVS repository. Same is for interproscan data. This is actually an easy config that is in the upstream repository. That's 45 gigabytes of data, and we just put it into oh yeah, that's one of my part, worldwide tour of the Canadian.
Right. Thank you, Bart. Any quick questions? Yeah.
So the build infrastructure, you don't actually have CVMFS mounted there. Like your /CVMFS is just a regular directory on your CVMFS?
Yes. Yes.
And then how do you keep that in sync? Like, do you do that every time you do a build? Or because otherwise you might have a difference between your build environment and your deploy environment.
Yeah, well, this is the rsync, basically. Publish a node to CVMFS, stratum 0. That's the step.
No, but I mean the copy on the CVMFS file system. How do you make sure that that is up to date when you do the build?
Well, because everything goes one way. So it's always newer than what's in CVMFS, unless we manually delete anything.
Ah, right. Okay. Yeah. Yeah. Fair enough.
Yeah, I thought I had. Did I delete that slide? Yeah. Okay. So yeah, on the publisher node there is a directory called CVMFS Ceph, and there's a directory called /CVMFS. When I mount the stratum 0, I just rsync from the CVMFS to the stratum 0 mount.
Another question. What about you mentioned you have different, let's say, generations.
Yeah.
It's now the standard M2023. How often do you install security updates in there for like glibc or is it just frozen in time forever?
It's frozen in time except when we see a really dire thing popping up. For instance, there was, what's it again? The XZ is in our...
Yeah. Because there have been cases where you ran into a CVMFS bug at some point by updating glibc, right?
Yeah.
Which has been sort of fixed, but not the 100%.
It has been fixed, but I haven't completely 100% verified it, so I'm still very careful when I do this.
Yep.
When it's just a binary, you don't have to worry. It's usually when it's a shared library, you can work around it with a couple symbolic links.
Yeah.
Absolutely sure you'll avoid it. Yeah.
Okay. If there's no more questions, we'll wrap it up here and we'll start our lunch break. Thanks, Bart.
Welcome.